All right, so very good afternoon to everyone. A very good afternoon to all of you, my dear students. A very good afternoon to all of you. So I'm hoping that all of you are fine and now ready to study the vectors further. So guys, we are into the part of kinematics, okay? And I hope you are enjoying the journey of physics with NEET Success Simplified channel and with me. Okay, so guys, I'm your very own physics educator, Dr. Umashankar, and in today's session, we are going to continue with the vectors. Okay, so we understand that the vector is a part of our fourth chapter as per NCRT physics book for 11th. Okay, and it is a very important part in understanding the various dimensions or various things of you know physics. Okay, it is widely used in kinematics, it is widely used when we are going to analyze the forces. Okay, okay, so let me introduce myself briefly. My name is Dr. Umashankar. I am PhD and MTech from Indian Institute of Technology, Roorkee. Okay, so now let's move ahead with this session of today. So guys, in the last session, what we have done. So in the last session, guys, we have spoken about the vectors, and particularly we have understood of addition and subtraction, right? Okay, so in the last session, guys, we have talked about the addition and subtraction of the vectors, and to remind you, we have solved questions, many lot of questions from both using analytical and graphical method. Hello, Bima. How are you doing, my dear? Have you watched the last session? I hope yes. So in the last session, guys, we have done with the addition and subtraction. And let me tell you again, that's the that's the subtraction was nothing. Subtraction was nothing but addition of two vectors. So this all this concept we have seen in the last lesson. Just giving you the brief overview. So now, if two vectors A and B are to be added, okay, there are two vectors A and B that is to be added, okay. So we did it graphically also, we did it analytically also, okay. So if we talk about the analytical way, so the resultant, so it comes up with a vector that is R. So resultant is root over A square. Okay, this is the mathematical expression for it that we have developed in the last session. A square plus B square plus 2AB cos theta. Okay, so this is how we analytically derived this very relation to get the magnitude of the resultant of two vectors when they are added. Okay, and what was the tan alpha? So alpha is the angle that we make from. So like this, so A is a vector, okay, B is a vector. Let's suppose the angle between them is theta, and you have the resulting, that is R, going from A. So this is your alpha. So we remember tan alpha is A plus B cos theta, and in the numerator it is B sin theta. So these formulas we derived in the last session, okay, for addition. And similarly for subtraction, which is nothing but addition only. So when we were doing A minus B, when we are subtracting these two vectors, the resultant, let's suppose, is R dash vector. So what was the magnitude of this vector? What was the magnitude of this vector? So it was under root of A square plus B square minus 2AB minus 2AB cos theta, minus 2AB cos theta. And what was the tan alpha? What was the tan alpha? Tan alpha is what? Tan alpha was, so A, and this is going to be minus B cos theta, okay, minus B cos theta, and this is going to be B sin theta, right? B sin theta, where theta is again the angle between A and B. Okay, I hope you remember that now. A and B. Okay, so theta is the angle between the vectors A and B. So if we are subtracting these two vectors, so basically the resultant that we are talking about, it is this R dash. This is this R dash. Okay, fine. Yeah, I hope it is fine to everyone. Yes or no? So this is going to be the R dash vector, right? This is going to be the R dash vector, right? Okay, okay. And here the alpha was, we are taking it again from the A vector. Okay, so I hope you remember all these things. Okay, so in the last session, guys, we have sorted this out, that how we do the subtraction of two vectors. That is nothing but addition of a vector with negative of another vector. So subtraction is nothing but the addition. We are using the rules, the understanding of addition only. Now let's start with some questions. Okay, so to better understand, because see, subtraction is very widely used. Okay, it is very widely used thing, right? Because lot of physical phenomena involve subtraction of physical quantities. Like for example, if we want to find the acceleration of something, we want to go for the change in velocity. Okay, even when we move to the forces, Newton's law, force is equal to mass into acceleration. From where this came from? Change in momentum, right? Okay, so again, the change, difference is very important to be understood as far as physics is concerned. Okay, okay, so let's start solving some questions so that we understand the whole concept in a better way. All right, so how we got to do it? So let's suppose a particle is there. A particle is moving. A particle is moving. A particle is moving with velocity. A particle is moving with velocity 5 meter per second. A particle is moving with velocity 5 meter per second towards east, towards east, and its velocity, and its velocity, hello Shizai, and its velocity changes to 5 meter per second north in 10 seconds. So we have just started, and we are seeing. So last session we have done this, addition subtraction thing. We learned that how to do, what are the insights to it graphically, analytically, right? In all the manners we have understood this thing. Okay, now we are going to apply the concept we have learned in today's session, and then further we'll be moving towards the resolution part as well. So a particle is moving with velocity 5 meter per second towards east, and its velocity changes to 5 meter per second north in 10 seconds. Now what we need to do, sir? We need to find the acceleration. Find the acceleration. Okay. Now I'll give you some options too. Let's see if we are able to do it or not. All right. Now let's try this. I'm very sure we can do it. Please go for it, my dear. Let's try to solve this question. I'm quite sure that we can do it. Please go for it. Please go for it. Very good, Shitai. What about you, Bima? What about you, Bima? Can you please answer me? She says today we started with the 75-day challenge also. So today we have done some 10 questions at 2 p.m. session. So you may watch them later. Okay. So every day now there will be a question session. I'll try to come up with, you know, at least 10, 15 questions we'll do every day. Okay. So if you are unable to join live, you can always watch the recording, and just like the live session, you can do that. Now please see. So a particle is moving with velocity of 5 meter per second towards east and velocity changes to 5 meter per second north in 10 seconds. Find the acceleration. Now what are we supposed to do? So now what happens? So we are having the velocity of 5 meter per second towards east. So something is moving. No problem, beta. You can always watch the recording. Okay. So the particle is moving with velocity 5 meter per second towards east and its velocity changes to 5 meter per second north. So something is moving. Yeah, yeah, no problem. So something is moving. This is 5 meter per second. Okay, this is 5 meter per second. So we understand that the initial velocity vector is 5 meter per second and final velocity vector is 5 meter per second moving in the north direction. So lastly also I have given you this concept. Now please understand this. So we very well know that the acceleration is the change in velocity upon change in time. Change in velocity upon change in time. So what is change in velocity, sir? It is vector v2 minus vector v1 and the difference of time in which this happened. Okay, time is a scalar quantity. So now this is time is 10 seconds clearly. Okay, now see here, this is v1 vector, this is v2 vector. But are we interested in v1 plus v2? We are interested in v2 minus v1. Now, again, the concept of subtraction came into picture. Okay. You need to do the difference of two vectors. That means you need to add. You need to add a vector with the negative of the other vector. Okay. So now what we can do? So we can reverse the direction of v1. Okay, we can reverse the direction of v1. Okay, and I can do the parallel shifting also. So whatever way you may want, you can go by the triangle law, you can go by the parallelogram law, whichever comes in your mind first. So if I reverse the direction, this is your negative of v1 vector, right? This is your negative of v1 vector. Its magnitude is still equal to 5 meter per second. Okay, 5 meter per second. So when I reverse this direction, now you can see that this vector of minus v1, yeah, this vector of minus v1, this v2, though both are in the same order. So now we understand that the resultant of it is going to be the the third side of the triangle taken in the opposite order. Okay, so this is going to be the direction of the resultant. And see, this is a 90-degree triangle. Both these are equal. So what we can say, it is going to be equal to 5 root 2. This is we have sorted previously also, na? Yeah, you got it yesterday. Okay, so this is going to be 5 root 2. So what is going to be the answer? So what is acceleration? So it is 5 root 2. It is 5 root 2 by 10 meter per second square, right? Meter per second square. And so anyway, it is going to become 5 by 10, that is root 2 by 2. So root 2 by 2 is 1 by root 2 meter per second square. And now what is the direction, sir? What is the direction? So it is obviously northwest, because this is 90, this is 5, this is 5. So this is obviously 45 degree. Okay, so you could do it by parallelogram also. If you not make it here, if you take this minus v1 vector at the tail, so you connect them tail to tail, you'll see the diagonal of the parallelogram. There also, from there also, you'll get the same answer. So it is going to be 1 by root 2 meter per second square in the northwest direction. I hope it is fine to you. Yeah, yeah, wonderful. Now let's move to the next question. Let's try one more question. See, very important concept. It is very much asked, very much used. So a car going due not at 10 root 2 meter per second turns right. 10 root 2 meter per second turns right. Okay, turns right through an angle of through an angle of 90 degree through an angle of 90 degree without changing speed, without changing speed. Okay, without changing the speed. The change in the velocity of the car is the change in velocity of car is. Okay, now speed is not changing. Can the velocity change? Yes. So speed refers to basically the magnitude of the velocity. So even though magnitude remains the same, but direction changes, and we know vector has two things: magnitude as well as direction. Okay. Now this is going to be. Let me write the options. Very good, Shitai. What about the rest of you? What about the rest of you? All of you can please solve. Bima and any other students who is live here, you can solve it. Okay. So having it nearly the same concept of that of what we have learned. Okay. Now what does this question say? So this question says a car going due north at 10 root 2 meter per second turns right to an angle of 90 degrees without changing the speed. So what does that mean, my dear? So basically a car is going to the north. Okay, so the car is moving towards the north, okay, with a speed of 10 root 2, and it turns right through an angle of 90 degree. It turns right through an angle of 90 degree. Yes. So are you going to give me some answer, Bima? Please always tell me if I'm going in a fast manner or something like that. Okay, I'll wait. I'll wait till you solve the question. Okay. So it moves towards the right. So basically the second vector is going to be like this. So this is obviously v1 vector, its initial velocity. This is the final velocity, that is v2 vector. So v1 vector and v2 vector. So what is the change? uh, हिंदी में बोलूँ मेरे भाई? बेटा ये चैनल इंग्लिश चैनल है ना दोस्त, मुझे हिंदी में बोलने में कोई समस्या नहीं है, लेकिन दिस चैनल इज अ इंग्लिश चैनल मेरे भाई, ठीक है? ये इंग्लिश चैनल है, ठीक है? अन अकेडमी का इंग्लिश चैनल है, तो यहाँ पे ना इंग्लिश में है सारा सिस्टम, ठीक है? तो हिंदी के लिए देखिए, कल भी मैंने रिकमेंड किया था, हिंदी के लिए आप अन अकेडमी के दूसरे चैनल से, वहाँ हिंदी में चलता है, आप वहाँ पे चले जाइए। अदरवाइज अन अकेडमी ऐप पे आ जाइए, वहाँ पे स्पेशल क्लासेस होती हैं, वो हिंदी में होती हैं, इंग्लिश में भी होती हैं। मैं अन अकेडमी ऐप पे हिंदी में सेशंस लेता हूँ, ठीक है? लेकिन ये चैनल इज अ डेडिकेटेड इंग्लिश चैनल, ठीक है? ये इंग्लिश चैनल है, तभी मैं इंग्लिश में बोल रहा हूँ मेरे भाई। गेटिंग माई पॉइंट? ठीक है। सो अ कार गोइंग ड्यू नॉट, अच्छा क्या बात कर रहे थे? सो so now in the north, the car started its journey in the north direction with 10 root 2, and then it took a right turn with having 90 degree without changing the speed. Okay, so yeah, thanks for understanding, my dear. Okay, so it took a right turn without changing the speed. So that means the magnitude remained the same and it took the right turn. Okay, it took the right turn. So now what we have to do? Now what we have to do? So what is the change in velocity? So the change in velocity is going to be the final velocity minus initial velocity. So final velocity minus initial velocity, that is v2 vector minus v1 vector. So what is this minus v1 vector? So what we can do, sir, so we can reverse the direction of this v1. Okay, that is going to be the negative vector now. See, you can apply the formula also, but that is going to be too lengthy. And also, it is not going to give you the direction rightly because you will be confused unless you understand the concept. That is why graphical method is very important. So now from here, we can say that the resultant is in this direction. And see, we can use some hacks also. So remember when two vectors are equal, so their resultant will be exactly in the middle of that what in the middle of that two vectors, so it will be 45 degree, again it will be 45 degree, and what is going to be the resultant, sir? So we did it many times. So each of the vector multiply by root 2. Okay, so the vector is 10 root 2 multiply by root 2, so this is going to be 20 meter per second. So you can apply the formula also, you are going to get the same thing. Okay. Okay, but what is the need, sir, when we can do it fastly? And I hope if you have watched the last session, you will be getting what we are doing here. Yeah, Srisai and Bima, do you got any problem here? No, please tell me. Let's not waste any more time here. Please tell me, will you be able to deal with these kind of questions or not? Very simple, change in velocity, change in something. You know how to use the formula also, and there is no importance, just it is, vector addition only. Okay, so now we are coming up with the 75 hard day challenge, so we can do some more questions in those things, right? So can I move with the concept? Do you want to learn uniform circular motion right here, right now? Hmm? Let's do uniform circular motion. Okay. So, see, if you are good at vectors now, there are a lot of topics that you can understand very easily. Let me come up with a question. So, this is question of uniform circular motion. Let's see if we can do it. So, a particle, it is a very important chapter. So, like if you see in the previous year analysis, almost 4 to 5%. Okay, so for to like 3 to 4 questions we can expect from this kinematics. Okay, and also it is the basic of dynamics, right? See, mass into acceleration, s is equal to force is equal to mass into acceleration. So that is the basic formula that is going to be used now. Now from where you are going to get the acceleration we get from the kinematics only, my dear. Are you getting my point? Now let's say we have slides a particle slides with a speed of with a speed of a particle slides with a speed of 5 meter per second at p. See, you have all the information to do this question. It's the only thing that whether you will be trying to do that or not. So when it reaches q, when it reaches q, okay, it still moves at 5 meter per second. Okay, and Bima, I want you to solve this question. Okay, this time after describing the angle of 60 degree as shown in the figure, as shown in the figure. Okay, as shown in the figure. Okay, okay. So you have to find the change in velocity. You have to find the change in velocity between P and Q. Okay, you have to find a change in velocity between P and Q, assuming particle followed circular path, from P to Q. Okay, एंड हमारे पास जो फिगर बना हुआ है, ओके, दिस इज द फिगर। तो देखिए, इसी को कहते हैं यूनिफॉर्म सर्कुलर मोशन। जब कोई बॉडी यूनिफॉर्म सर्कुलर मोशन में होती है, ये है पी आपका कहीं, ये है क्यू आपका कहीं, ठीक है। तो कोई बॉडी यूनिफॉर्म सर्कुलर मोशन में होती है, तो इसका क्या मतलब है कि आप उसको किसी, जैसे आपने क्या किया, सो वेन एवर इज समथिंग इज, अरे मैं हिंदी में तो हिंदी में बोल रहा था क्या, सो वेन एवर समथिंग इज इन uniform circular motion. So like you can take up the example. So there is a string. Let's suppose we are having a string, and we have tied up a stone over it, and you are rotating it like this. This is something like uniform circular motion. So if any body, any particle is following a circular path, and its speed is not changing, not velocity, its speed, that is the magnitude of the velocity is not changing altogether. At any point, if you observe, the velocity remain the same. This is what we know as the uniform circular motion. So a body moving in a circular path without any change of the speed is nothing but uniform circular motion. So here the angle between P and Q is given to be 60 degree, and your velocity here is the velocity vector, and here it is the velocity vector. Here it is the velocity vector. Okay, okay. Now please try solve this question. I'm very sure we can do it. Okay, okay. This is 90 degree. This is also 90 degree. Please solve it. Let's see if we can do it or not. Please go for it. I'm very sure we can do it. Bima, this time I want you to answer as well. I'm waiting only. I'm waiting. Now with this question, we'll complete the uniform circular motion to some extent as well. Then I'll be generalizing it. Don't worry. Bima, I want you to answer as well. Please do it, my dear. Take your time. No worries. No, no. I don't want the answer in Cartesian form. Cartesian we haven't started yet. So I don't want the answer in the Cartesian form. I want change in velocity. That means I want the direction of this and the magnitude of this. Two things I want. Direction and magnitude. Two things I'll be requiring here. See, you don't have to use any. See, all the concepts are with you. First, try to understand it. All the concepts are with you. So, what about you, Bima? Are you getting it or not, my dear? See, if you are feeling any difficulty, feel free to ask me, Vida. See, unless you ask, how would I know? Yeah, magnitude is correct. See, sign. Can you figure out the direction as well? Now it says a particle slides with a speed of 5 meter per second at p. When it reaches q, it still moves at 5 meter per second after describing the angle of 60 degree as shown in the figure. Find change in velocity between p and q, assuming particle follows circular path from p and q. So that means it is an example of uniform circular motion. No, okay, just you can watch me. Okay. Now let's see what is happening. Let's see what is happening here. So see, it is nothing just the use of the concept of vector. Okay. Concept of vectors. So now please understand this. I'll tell you something. Now this is P, this is Q. Okay. And the angle between this is 60 degree. Now I tell you what. So in a uniform circular motion, see, small points, if you remember, na, that is going to be very, very helpful in the long run. See, the angle between two vectors or angle between the vectors made at 2 points, angle between the vectors. So it is not exactly the correct statement. See, whatever angle is going to be here, okay, between these 2 points. Okay, so there is some exception to it. Not exception, but you have to be smart while using this concept. Are you getting my point? Okay, so whenever you are going to make this vector, whenever you are going to make the parallel shift, you are always going to get the same angle between them. This always happens in the case of vector. I'll just prove it. No worries, I'll prove it. But there you have to be careful with one thing. Okay, what is that thing, sir? So if the angle between the 2 points is 270, so the angle between the vector will be, see, here it is 60 degree. Now the angle between these two vectors is going to be 60 degree. I'll just prove it to you. I'll just show it to you. But what if the angle between these 2 points is 270? What then what? Then what? All 300. Okay, like that. Now in that case, because you know the angle between two vectors can never be more than 180. So if it is given like 270, so that means the angle between vector is nothing but 90. 360 minus 270. We'll come to it. Don't worry. We'll come to it. We'll sort it out completely. Now please observe. This is 90. This is 90 obviously. So if I do some parallel shifting, can I make this V here? Right? Can I make this V here? Yeah. No, 90 and 60 three side. I'll come to that. Just let's conclude this one. So if I do some parallel shifting, I can take this V here, right? Do you agree or not? Please answer me. Yes, sir. Now, what is going to be the angle between these two? What is going to be the angle between these two? So the angle between these two. So see, this is 90, this is 60. This is 90, this is 60. So if I extend a perpendicular here, if I extend a perpendicular here, so this is going to be 90, 60. So this is going to be 30. This is going to be 30. Now, if this is 30, if this is 30, so if I shift it, so if this is 30, so this is obviously 60, right? So I just shifted it here. Okay, so the angle between them is also 60 degree, isn't it? Angle between them also 60 degrees. So I'm making these vectors here. So this is the initial vector, and this is your final velocity at q. Okay, okay, so let's call them v and v. So this is also given. So can I write it as v1 vector? So when I write v1 vector, and this is not v1 vector, but this is v2 vector, right? Because the direction is changed, na, though magnitude is same, 5 meter per second. Now, do we have to find the resultant between these two? No, sir. No, sir. No, sir. Because you wanted to find the change in velocity, guys. So change in velocity is v2 minus v1. v2 vector minus v1 vector. v2 vector minus v1 vector. Now, when we want to find the v2 minus v1 vector, when we want to find the v2, oh, I have made a mistake. This is v1 actually, na? This is v1. This is v2. This is the final. This is for the point q, na? So this is v1. This is v2, right? Okay. So basically, when you are finding the change in the velocity, when you are finding the change in the velocity, sir, you need to find v2. So you are finding the resultant between, you are adding vector v2 with negative of v1. So what is negative of v1, sir? We can reverse the direction of v1, and this is going to be the negative of v1, right? So basically you are going to find the resultant of these two. Now if this is 60, this is going to be 120. So right away you can find the resultant of this. So resultant will be, so when two vectors are equal, so the resultant will be exactly in the middle of these two vectors. No calculation required. No calculation required. Yes or no? Yes or no? Please answer me. Please answer me. Yes, obviously, sir. Wonderful. Okay, we come to understand that. Now, if we want to find this change in velocity, so we can use the formula directly. Okay, what is the formula? So 5 is square, v1 is square plus v2 is square. v1 is square, magnitude of v1 is square plus magnitude of v2 is square minus 2v1 v2 cos theta. So here the theta is going to be, yeah, she's saying. So when you are, see, so this will come with practice only. See, if you mix the graphical and analytical, the best approach comes when you mix both methods to reduce your time. Are you getting my for example, if you see the way I solve, I use both the methods. Okay, wherever I find it easier, right? So it will happen. Don't worry, it will happen. So the change in velocity is root over v1 square plus v2 square minus 2v1 v2 cos theta. So now what we can do, we can write change in velocity is equal to root over v1 square, so it is 5 square plus 5 square minus 2 into 5 square. So here, should I use 60 or should I use 120? That could also be done, but it is a longer process. Okay, you gone for resolution, then you do the Cartesian form. That is big process. Why to do that? Okay, we'll learn how to do it though. I'll try to come up. I'll try to do this in this session only. Okay, when we'll do the resolution, writing the Cartesian coordinate, dealing in the Cartesian way. Okay, but that way it is going to be longer. Now you tell me, in this, should I put 60 degree or should I put 120? Be my you also. So, sir, always remember, sir, we need to put 60 only, because as I keep telling you that whenever you are using formula, this theta is the angle between vector A and B. This is not the angle between vector A and negative of B, right? Okay, so be careful while you use the formula. So it is going to be equal to 5 meter per second. So how come? So this is 5 square and this is cos 60. So 2, 1 by 2 cancel out. 5 square minus 5 square, it is going to become 0. So we will be getting it as 5, right? We will be getting it as 5. I hope it is clear to everyone. So this is the magnitude of it. And by doing this thing, you can know the direction of this resultant. Understood, Vida? Understood? Okay, right? So this was uniform circular motion. Now let's generalize this thing. Let's generalize this thing. Let's suppose we have a body, we have a particle. So we are going to generalize this now. Now please observe. See, this way you will be able to deal with the uniform circular motion in a more better way. So let's suppose that a body started from here and then after some time it reaches here and it followed angle theta. It followed angle theta. Okay, it followed angle theta. So now always remember that see in uniform circular motion the speed never changes. That means the magnitude of velocity is never going to be changing. Only the magnitude of it is going to change. Only the magnitude of it is going to change. So this is going to be like this. This is going to be like this. Okay. 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 Now can you give me, and always remember that this velocity vector, the linear velocity vector, is always perpendicular to the radial line. Okay, so this is the radial line. Huh? Now, can you make one formula for me for change in volume? Okay, and I always tell you, see, I want your answer. I want your answer, your formula in terms of V and theta. I don't want to see anything else other than V and theta. Can you find me a formula between these two so that we can use it further? Just the resultant, just the magnitude of resultant. Can you please try it? Please try to do that, Vida. Let's try it. No, no. See, V1 and V2 both are same only, na, my dear. Okay. So you can generalize this formula, na. See how you can do it. Please try it. Try to make the formula in terms of what is V1, what is V2. I don't know. See, when I have given you the information in terms of V and theta, the final answer should be in terms of V and theta only. Okay. So what is this V1, V2? Are you getting my point? Please try to do that. आई एम वेरी श्योर यू कैन डू इट, कोई बड़ी बात नहीं है. Please try to do it. No, wrong answer. Okay, let me do it. Let me do it. Now, first of all, First of all, see what we are trying to do. So firstly, this is uniform circular motion. How come, sir? Because the particle is following a circular path and its speed is not changing. So if these two conditions are satisfied, yeah, now it is correct. Now we can sort it out even further. Yeah, yeah, she's saying good. Now please observe. So here, this is the uniform circular motion. So how we will understand in a problem that the problem is of uniform circular motion. So this is very, very simple. So if a body is following a circular path, if a body is following a circular path, okay, okay, and its speed is not changing, that means the magnitude of velocity is not changing, just the direction changing, then this is a example of uniform circular motion. Understood? Okay. Now this is uniform circular motion. So what we are trying to do here, so we are trying to generalize the formula of change in velocity, because in uniform circular motion they ask you questions to find the change in velocity, right? So we are trying to generalize this formula in terms of v and theta. So how we are going to do it? Let's suppose this is, p and this is q. Okay. Now if I do some parallel shifting, this I can bring it here, and obviously the angle between these two is going to be theta. See, you don't have to check it again and again, but if you want to check it, you can obviously check it. So this is theta, this is 90 minus theta, this is theta, this is 90 minus theta. So if I join this, okay, this is theta, this is 90, this is 90 minus theta, so this is theta, so this is theta vertically opposite. So any way you want to see, you can see. Any way, if you want to see, you can see. Or you can say, so if you bring it here, if you bring this vector here, okay, so if you bring this vector here, so let's join this line like this. Okay, so this is 90, this is theta, this is 90, this is theta, 90, 90 minus theta, so this is theta. So anyway, either you can take this second vector, yeah, in second. That is what I am trying to do. Okay, that is what I am trying to do exactly. Now see what we are going to do. So this is v, this is v. Okay. So let's come to this. So I'll make it outside. So this is v, this is v. Okay. Now what is v1? This is v1 vector. Its magnitude is v. And what is this v2? This is v2 vector. Okay. Its magnitude is also v. Its magnitude is also v. Now, sir, what we need to find? The change in velocity. So here we can directly use the formula now. Sir, v2 vector minus v1 vector. If we want resultant also, we can, so we know. Now this is in our heart now. That, sir, we are writing v2 minus v1. That means we are adding this v1 and, sorry, we are adding this v2 and negative of this v1 vector. I think this is in your mind now. So if they ask you the resultant, this will be the direction of resultant. You can have it calculated. Okay, that is not a matter. So let's directly use the formula. So what is going to be delta V? So it is going to be V2. So V2 is V plus V1. So I'll write the formula first. V1 is square plus V2 is square minus 2V1 V2 cos theta. So it is the formula in the case when there is minus in between. Okay. So now if I put the values, so can I get change in velocity is root over, so V1 is V is square, V2 is V square, V1 is V square, V2 is V square plus, sorry, minus 2V square cos theta, 2V square cos theta. So from here, can I write change in volume is equal to 2 times V square 1 minus cos theta, 2 times V square 1 minus cos theta. Or either this formula is too complicated to memorize this way, root 2V square minus 1 minus cos theta, too complicated. Let's simplify it. Now, do you understand that 1 minus cos theta is also 2 sine square theta by 2? We did it in the motion in the straight line part also. Sir, how come? Okay, I'll tell you. So, see, some basic trigonometric formulas you must know. So, cos 2 theta is equal to 1 minus 2 sine square theta. We know this formula. So, from here, can we write 2 sine square theta is equal to 1 minus cos 2 theta? 1 minus cos 2 theta. So that means 2 sine square theta by 2. So this 2 theta becomes theta. So this is going to become theta by 2. 1 minus cos theta. Now can I replace this 1 minus cos theta with 2 sine square theta by 2? Yes sir, of course you can do. So 1 minus cos 2 theta, 1 minus cos theta replaced by 2 sine square theta by 2. It will become 2 into 2, that is 4. V square sine square theta by 2. So from here can we get the change in velocity as 2 times V sine theta by 2. Okay. Okay. So now this is the general formula that you can memorize also. Okay. To save some time. See, uniform circular motion is, very hot topic. Why it is hot topic? Because you are getting so many questions out of it. Now you all know, you guys see the NEET PYQs. Okay. I think students these days are very, very smart, very, very attentive, very, very forward also, right? So you know everything, right? So now since this is, very frequently asked thing, I would suggest that you memorize this formula, simple formula. Change in velocity is 2v sine theta by 2. So this way you hold this uniform circular motion topic pretty nicely. Because see, what kind of a question they ask you generally? Okay. Sir, a particle start moving and it took half revolution. It took quarter revolution. It took three-fourth revolution. It took 5/6 revolution. Or another way, like the previous question, a particle moved from some point and then moved by 60 degree, then followed 60-degree path, okay, in a circular section. So whatever is the theta, you can use directly this formula. Now see, like if you go back to this question and directly use this formula, then you do see, in physics not only you have to know something, you have to solve it in less time also, na. So change in volume change in velocity is what, 2v sine theta by 2, so 60 by 2. Now v is given as 5, and sine 60 by 2, that is sine 30. So sine 30 is 1 by 2, 2 is cancelled out, you are going to get 5, right? You are going to get 5 meter per second. Okay, so whenever, now they can twist the question also. So they may ask you that in what condition the change in velocity is equal to the velocity itself. Let's say a body is moving with a uniform circular motion. Now, what is the position between the initial and the final velocity if the resultant of the velocity is equal to the magnitude of the speed itself? Yeah, even without pen you can do, right? So 60 degrees. So remember the 60-degree thing. Are you getting my point? Are you getting my point? Okay. Now let's get back. Okay. Let's get back. Actually, just tell me one thing. Okay, I'll just show you. So let us grab. Yeah, yeah. There is something missing to it also. It could be 30 and 60 and 300, right? Okay, 60 and 300. Okay, we'll understand it. Don't worry. Let's do it in another way. Okay, so let's generalize. Let's see what kind of a question they may ask you from it. Okay, so let's generalize it. Let's make a question out of it. You'll understand. Don't worry. So see, a particle moving, a particle moving with, a particle moving with constant speed, a particle moving with constant speed. Very good. She's saying constant speed of 100 meter per second. A particle moving with constant speed of 100 meter per second. Find the change in velocity after. Find the change in velocity. Bima, I hope you are getting everything now, because you are not, answering in the chat. Okay. But I hope you are getting everything. See, always feel free to ask me anything. Okay. which is related to the topic of the session. Okay, I'll be more than happy to answer that. Let's say half revolution. Okay, then we can go for 1/4 revolution. Okay, then we can move to 3/4 revolution. Then we may move to 3/4. Then we can move to 5/6 revolution. 5/6 of a revolution. Now, what I mean here, see, what I mean here, see, a particle moving with a constant speed of 100 meter per second, find the change in velocity after half revolution. Now, half revolution. So, a particle started moving with a constant speed of 100 meter per second, and now it has moved by half revolution, then by 1/4 revolution. So, in each of these conditions, you need to get me the change in velocity. Please go for it. Please go for it. Let's try to find it. Take your time. We'll see. Bima, you also do. Yes, please do that. How you going to do it? कैसे करेंगे? See, very, very simple it is. Yeah, I was just drinking some water. Okay, now I'll do it. Now I'll do it. So now it says a particle moving with constant speed of 100 meter per second, find the change of velocity after half revolution. Okay, wonderful. So we know that we have generalized the formula. So change in velocity is 2v sine theta by 2. Okay. Now please imagine that when a particle moves, so we have to be quick also. So when a particle moves by half revolution, so how much angle it has done from its initial to final? So obviously, sir, when a path has taken, so let's suppose it is started from here, and now after half revolution, so obviously it must reach here. Okay, it must reach here. So the angle moved is 180 degree. So what is going to be the change in velocity in this case? The 2v sine 180 by 2. So sine 180 by 2, that is sine 90 only. So sine 90 is 1. Now the velocity is given to be 100. It could be 150, 200, 500, whatever it is. What is your concern with that? Now 2 into 100, that is 200 meter per second. Right? Okay, so this is your initial velocity vector and this is your final velocity vector, right? This is also, I think you can imagine, right? Yes or no? Now, if you think it graphically also, see, any way you do, graphically, analytically, you are going to get the same answer. So this is V2, this is V2 vector, this is V1 vector. Now you want to find V2 minus V1. So simply you can reverse its direction now. This is your minus V1 vector. So see, two vectors, the angle between them becomes 0. So when the angle between them becomes 0, their magnitudes are added. Okay, so you have learned all the ways now. So whatever is your, I don't think that there is any, bottleneck remains in your mind. You know now this happens this way also, that way also, any way that comes in your mind. Am I right or wrong? Right? I hope you are having the crystal clarity in this concept. Now, 1 by 4th of a revolution. So, 1 by 4th of a revolution means that this particle started moving from here and then it moved till this point. It took a quarter turn, 1/4 of a revolution. So how much is 1/4 of the revolution? So it is 90 degrees. So it has moved 90 degrees. So this is this and this is this, right? Okay, these two vectors. Okay. Okay, so what is going to be the change in velocity? So it is going to be 2v sine theta by 2. So it is going to be 2v sine 45. Okay, so sine 45 is 1 by root 2. Sine 45 is 1 by root 2. So it is going to be 2 into, this is going to be 2 into 100, 2 into 100, and sine 45 is going to become 1 by root 2. So basically, change in velocity is going to become, in this case, 100 root 2. Okay, 100 root 2. And see, remember, see, root 2 value, root 3 value, all these values you must memorize. Root 2 is 1.414, right? Okay, this also you must know. Okay, sometimes in options they can use that too, right? Now coming to 3/4 of a revolution. So 3/4 of a revolution, one revolution is 360 degrees. So 3/4 of a revolution obviously is 270 degrees. Now here is one thing. Now please understand this. Please understand this. Now see, this is the initial position, V1 vector. Okay, and now this particle, now please understand that this is important. Now this particle has followed this way, 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 this way. Now this has reached to this point. This has reached to this point. So this is going to be the V2 vector. Now many students, what mistake they do, they forget the basic and they say the angle between the vector is 270. Now can the angle between the vector be 270? No sir, because angle between the vectors is the one when you join the vectors tail to tail and you see the smaller of the two angles, right? So basically when you see this is 270 degree, so the angle between the vector is 90 degrees. So here use theta as 90, not 270. Are you getting my point? Okay, so what is going to be the change in velocity, sir? Right? So this is going to be equal to 90 degrees. So this is going to be 2v sine theta by 2. Okay, theta by 2. So now it is going to be 2v sine 45. Now please understand it. This is what I was trying to tell you, but now I think it is going to be more clear. D is equal to 100. What is D? Velocity is 100, na? No, no, not diameter. What do, if D you are referring to diameter, what would you do with the diameter here in this case? There's no work of diameter. You didn't get it, what we did. Yes or no? Did you get it or not? Hmm? Is there a problem, beta? Question number D. This is D also, na? You didn't saw it. No, no worries, no worries, no worries. Okay, so now please listen to me. So this is going to be 2v sine 45. So it is going to be again root 2 into v. Now in this case, this v is 100. Now please understand this. Please understand this. So this is 100 root 2. Now you see, please understand this. One observation. Yeah, I'll just get back to you on that. Yes, the answer is that only. Okay. Now please understand this. See, if you observe this concept, so if let's say this point is 1, this point is 2, this point is 3. Now please understand this that the velocity, when you are seeing the change in velocity between 1 and 2 and between 1 and 3, the change in velocity magnitude is going to be the same. Are you getting my point? Are you getting my point? Because in the world of vectors, okay, in the world of vectors, it happens to be like this. Are you getting my point? You just have seen it now. You did v2 minus v1 and you did v3 minus v1. Both were same. Both were same. Because when this moved at 270 degree, when this is moved by 270 degree, again the angle between the vectors is 90. And we very well know the resultant of two vectors depends upon the angle between them. So when the angle between the vectors are not changing, from where the resultant would change. Are you getting my point? Please answer me. Yes or no? Yes or no? Okay. That is why I told you that if at all it is asked. So when I was explaining you here, I said one thing that if it is asked in the question that at what angle do the particle has to move so that it is speed, the magnitude of the speed and the magnitude of the resultant becomes same. Okay, so it was 60 and 300. It was 60 and 300, right? Because now similarly you can see for 90, when the angle is 90 and 270, this is 270, right? We are getting the same difference. I hope this is clear now. Now what is going to happen in 5 by 6 of revolution? So the angle is 30 degree, but I think you get this now that theta we have to take 60 degree, because the angle, she said, I didn't notice that, my dear. I didn't notice that. Okay. See, randomly, maybe someone came and say something, so we don't have to now address that. Are you getting my point? So here, this is a lot of free space now. Like YouTube, anyone can come and say anything. So you don't have to think all this. You'll have to do your work. This is for me also, na? Okay, right? Because see, it is an open space. Anyone can come, can say anything he likes to. Okay, but we don't have to address that. We don't have to entertain that. We can do our work, right? Okay. So here theta is going to be 60 degree. Okay. Now theta is going to be 60 degrees. So what is the change in velocity? So we know it is going to become 100 meter per second only. Because when the angle between the vector is 60 degree in uniform circular motion, the magnitude of the resultant is similar to, okay, the magnitude of the resultant is going to equal to that uniform speed itself. So the change in velocity is going to be 100 meter per second. Now please tell me one thing. Now please tell me one thing. Now do you feel that we have understood the concept of uniform circular motion as well? Yeah? Please answer me. What do you say? Yes or no? Bima, you also, my dear. So in uniform circular motion also we use the concept of vector addition only. Yes or no, beta? Please answer me. What do you say to that? Please do ask me. Yeah. 300 degree. So 5 by 6 into 360. One revolution is for 360, right? One revolution means something has rotated by 360 degree. So 5 by 6 of this 360 is going to be 300. Yeah, didn't it? So how I get 270 here? So 3 by 4 of 360, that is 270. Half revolution, 1 by 2 of 360. One revolution is of 360 degree, right? We know it now. Okay, so that is what we are doing here. Okay, I hope it is fine. Yeah, yeah. Same way everywhere, 1/4 of a revolution, that is 1 by 4th of 360 degree. Right? Did you get it or not? Yeah? If I say 1 by 6th, only 1 by 6th of our revolution. So by what angle a particle has moved from its initial position? If I say 1 by 6, then how much a particle would have moved from its initial position? Can you tell me that? ठीक है? 60 degree. Right? Similarly, if I say 1 by 9th of a revolution, 1 by 9th of a revolution, 1 by 36th of a revolution, 1 by 18th of a revolution. So all this thing you will be able to do, right? Simply you have to multiply it with 360 degree, right? Now let's move forward. So now I hope that you are now having no difficulty in the basics of vector, that is the representation of vector, angle between the vector, okay, parallel shifting, then graphical method of this vector calculation, okay, finding the resultant, then analytical method, that is law of parallelogram of vectors, right? And moreover we have seen subtraction also in different way, but I hope everything is fine till now, right? Now we shall move to a very very important part. We shall further move to a very very important part of we shall move to the very very important part of this particular topic, that is the resolution of the vector. Now please understand this. See, resolution is something which is very very important. See, if I start telling you now the use of resolution in our physics, there is no end to it. Many chapters are requiring this use. She said, see, lastly, or see, I believe in only, see, I'm a very simple man, let me tell you. Okay. So, see, in my experience, okay, I feel one thing very simple. Simple belief I have. So, if you study something, it is going to become easy for you. If you are not studying something, it will remain difficult for you. Simple logic. Okay, so you are saying, sir, is 12 difficult? It is how it is difficult. People are passing it now, right? People are passing it. So, see, this is not difficult. Anything is difficult when you are not good at it. And why you are not good at it? Because you are not studying it properly. That is the only way. Okay. And there is only one solution to it. Okay. One can tell you so many tricks, do this, do that, do that. I tell you one thing very clearly. There is only one thing that you can do is study. Okay. Okay. Counter it. Okay. And definitely it is going to come in falling into the place. Trust me on that. Okay. Yeah. So when you are not practicing, that is the reason why you are feeling difficult. So now if I ask you, like, so someday, like not today, someday, so you had some knowledge of vectors previously also. Okay. But do you feel that vector becomes little bit more easier to you now? Yeah, definitely you can. So if till now, whatever we have learned here, you are understanding those things now. You think? So why not you will be able to, understand from here, right? Simply, so when you understand everything till now, definitely you are going to understand later also. So it is getting too easy because you have understood the concept. When you understood the concept of something, it becomes easier to you. Okay. If I start telling you a concept of, engineering, okay, I am a mechanical engineer. I have doctorate into it. So if I start telling you one concept of mechanical engineering, right now that concept you don't know, it will be the toughest for you. Now once I tell you, once I explain to you, and you given enough time to understand that, you given even concentration to understand that, then it is no more be difficulty for you. Right? Simple concept. Okay. Okay. Now let's move further. So definitely we'll move to physics 12th class also. But as I previously also said that, see, we also have some limitations. We are working in an organization, right? So we have some guidelines to follow. Okay. Now, according to that, I have to move in a serial manner, right? And according to the NEET syllabus, I cannot skip topics in between, right? Okay. So that is why, see, I can merge some topics. So that is, see, this is how what I could do. I'm trying to do that. Okay, so I have merged, this motion in a straight line, motion in a plane, but I cannot switch between the topics, right? I have to follow the, series of, the need syllabus. Okay, so I hope you understand that. So let's move to the very very important part. That is the resolution of vector. Okay. Now please listen to me carefully. See, this is something which many of us think that they already know. Okay, this is true to some extent, but still I want you to listen to me very very carefully. Okay, because what happens, see, in the same way vectors are, everybody knows that this is tail, this is head, length gives the magnitude, but the way we used it, okay, these all information, no matter how small it seems to be, how irrelevant at times it seems to be. But in physics, every single information, every little information is important. Okay, and it helps you solve the question correctly. So please listen to me very, very carefully when we describe you the resolution of vector. So basically, what is the meaning of resolution of vector? So it simply means that we are trying to find the components of something. Okay, components of something in two mutual perpendicular directions. So let's start with, so let's suppose this is x, this is y, this is the general way. Okay, now we have seen in vectors that vectors are given by magnitude and direction. So for vectors, direction is very important, magnitude is very important. Now, we have seen the problem. So, something is moving in east direction, something is moving in north direction. Okay. Now, if at all something is moving like this, let's suppose something is moving like this. Okay. Something is moving like this. It could be anything. It could be, let's call it a. It could be velocity. It could be force. It could be any vector quantity. Okay. But let's suppose that this is something a like this. Okay. Now, when I do this a, do you believe that this is a vector which has some component, okay, in x direction, okay, and it has some component in y direction, okay. So, for example, if this a is displacement, okay, so you have moved in both x and y. So, we are interested in knowing, we are interested in knowing we are interested in knowing what we are interested in knowing that what is the we are interested in knowing that how much we have moved in both x and y. Okay, so this is the way where, acha, thank you bhai, you are Chalo. So let's come to the point. Okay, let's come to the point. So we have this. So now see, when we are moving in both x and y direction, so that means that we have moved to both in x and y direction. So what we are interested here in knowing, Ranka. Thank you, my dear. Thank you, Shitai. Okay. So now when we are moving in both x and y direction, we are interested in knowing that how much we move in the x and how much we move in the y. This is nothing but the component. Now simple thing. See, it must be in your heart. See, you see a vector right away in your mind. You are seeing one vector in your mind. There must be the resolution of it as like you are seeing anything, right? It must be with your heart. So if this angle is theta, if this angle is theta, so now I can see a triangle here. See, I'll keep it very, very simple. So we can see a triangle here. Let's say M and P. Okay, M and P. So what is going to be the base of this? What is going to become the base of it? So the base of it is going to become A cos theta, right? And this AY is going to become A sin theta, right? A sin theta. How come, sir? See, we have this triangle MNP, this angle is theta, and this is hypotenuse, and the length of this hypotenuse is A, because the length of the vector is given by, sorry, the magnitude of the vector is given by the length of the vector. So the length of this MN is obviously A. The length of this MN is obviously A. Okay. Okay, so the length of this vector is obviously A. So the component of this vector in x direction is going to be A cos theta, and in y direction it is going to be A sin theta. And there comes, a scope of confusion. See what happens, my dear. What happens, my dear? So I have seen many students memorizing this thing like that. That's Many students are memorizing this thing this way. That's the component of some vector in horizontal direction, that is x direction, is having the cos component. Okay. Okay. And see what I was saying. So okay, let me come back to the point. Okay, so just got distracted with your chats. Yeah. So now, see what students have wrong conception in their mind. That's the horizontal component of vector is always cos theta, and the vertical component is sin theta. See, you don't have to think like that. See, very very simply. Now, please understand this. See, I'll make it very simple to you. So, if this is x, this is y. See, a vector making angle with the x-axis. Okay, a vector making the angle with the x-axis, this is going to be Raj. Uh, so, beta NEET is the examination. It is the entrance examination for the medical entry. Okay, so see, no one can wake up in the morning and go to some medical college like AIMS. Okay, I want to become a doctor. They don't let you in, right? Okay, the guard will throw you out. Okay, but if you qualify this examination NEET with good numbers, they will be welcoming you. Okay, so it is a entry point to medical college. Okay, now please understand this. So see, when angle A, when vector A is making the angle, no, Shri, nothing to be sorry about. So vector A is making the angle theta with x-axis. So that means it is having a component of A cos theta, and the y-axis, okay, it is going to become A sin theta, right? A sin theta. Okay. Okay. So see, what you have to remember, what you have to understand is that, sir, you don't have to know do the sine cos thing. You don't have to memorize the sine cos thing horizontally or vertically. See, you have to see that this angle, the vector is making the angle with what mutual perpendicular axis. So if this is A, this is theta. Now in this case, this is going to become A cos theta, because see that theta is with y axis. Hello, Abhay. And here in this case, it will become A cos theta. Are you getting my point? So simple way is that the vector is making the angle of theta with whatever axis the cos component is going to be in that axis. Is it fine, beta? Please answer me. Is it fine? Yes or no? Okay. Like for example, let's suppose there is a vector A. Okay. And here this is alpha. This is not necessarily always theta. It could be alpha, it could be anything. Now can you get me the component of it in x and y direction? Okay. Okay, so very simply, it will become, it will go into your mind right away. So, sir, how we are going to do it? So, this is a vector. This makes an angle of alpha with this axis. So, if you want to take the component of it, okay, you can write a cos alpha. See, cos comes. It is not a matter of horizontal. It has nothing to do with horizontal or vertical for that matter. Only the thing you need to remember is that whenever we are making the angle, whatever we are making the angle, whichever axis is having the angle with that vector, you are going to have the cos in that axis, and the axis perpendicular to this will have the component of sine. Okay. Okay, so this sine alpha is from where it came from. So this is 90 minus alpha na? So you can write this as a cos 90 minus alpha. So a cos 90 minus alpha, so cos 90 minus theta is equal to sine theta. So from there the sine thing comes. Okay. But not always, sir, we have to do this 90 minus alpha thing. Na? It is going to take more time. So that is why we have to remember this way. Understood? Understood? Please tell me yes or no. Okay. Okay. So let's suppose that we are having a force. We are having a force of 10 Newton acting at 30 degree from x-axis. Okay. Can you get me the component of it in x and y axis? Can you please get me the component of it in x and y axis? Very, very simple. Okay. And what is the idea? See, remember what is the idea behind the resolution? Because see, something can move in any direction, but that direction will depend upon the general x, y, and z direction. So here I'll be talking about this x and y because two-dimensional we are talking. So when we are talking in two dimensions, see, anywhere you move, anywhere you move, any vector which you are making here, it depends upon x and y. So we want to know that if there is a vector, what is the contribution in a way from the x direction and what is the contribution in y direction. Okay. That is the basic reason. That is the basic reason of doing the resolution. Later we'll be, taking this thing up with the Cartesian coordinate. Right? Okay. So what is going to be the components? It is going to be 10 cos 30 and this is going to be 10 sin 30, right? Okay. Because we know that the vector is making 30 degree from x-axis. So the resolution of this vector about this x-axis is going to come with the cos component, and perpendicular to x-axis is going to be the sine. Now let's suppose this is 5 Newton and this is 60 degree. Okay, can you get me the components of it? Can you get me the components to it? Very, very simple. I think you can do it. Yeah. How you can do it? What about the rest of the students? You can also try to respond better. What about the rest of the students, my dear? बाकी लोग, Bima and the other students. Okay, so how we can do it? So, sir, very, very simple, sir. Very, very simple, sir. Now, this is making 60 degree from this axis. So, there will be, it will be 5 cos 60. So, to whichever axis the angle is formed from, we'll get the cos component in that axis. And, sir, we get the sine component in the other perpendicular axis. So, this is going to become 5 cos 30. If I write it 5 cos 30, will it be wrong? No, sir, this is right only. This is right only. 5 cos 30 sin 60 are the same thing, same thing. So whatever comes in your mind first. So this is going to be sin 60. Okay, so remember the cos and sine don't only come in horizontal and vertical. It can come anywhere. I hope this is clear to you. And see, this is going to be have an extensive use. So later on, you will be going to see a lot of things. Okay, so let's suppose we have a string, and to string it, we are having a ball attached. Okay, now there will be some tension on this string. So what is the tension? What do you mean by tension? So tension will come to it, but it is basically a kind of force. Okay, it is basically a sort of force. Okay, it is basically a sort of force. Are you getting my point? It is basically a sort of, force. Okay, wonderful. Now please understand this. So we are having this T. Now if I say, now please understand this. If I say this angle is 30 degree, can you get me the component of this tension in x and y direction? Can you go for it? Please try to tell me. Please try to tell me. What are the components in x and y direction? The remaining students, beta. What about the remaining students? Any answer? So see, sir, please understand this. So whenever you want to resolve a vector, so here T is a force, so this is a vector. So you must be having the clear thing of the direction, of the angle. So you need to know the angle between the vector to the axis. Okay, so this is 30, this is T. Now this is obviously 30 degree. This is obviously 30 degrees. So this is going to be how much? So this is going to be T cos 30, T cos 30, and this is going to be T sin 30. This is going to be T sin 30. Is that fine, beta? Is that fine? Okay. If one sort this angle as 60, this will become T cos 60, and T cos 60, T sin 30 are the same. Sorry, right? Okay. It's getting cold here. Actually, this is, Roorkee is very nice place to live in. Okay. Very, environment friendly place. So cold, it's getting here. Okay. These days. Okay. Very good. Wonderful. So T sin 30 and T cos 60 are the same. Now, similarly, if you have considered this as 60, T cos 30, you can write here. So if this is 60, so let's suppose you have considered this 60. then also there is no problem. Okay, there is no problem. Okay, so what I'm trying to tell you here, see this, see, so we have this 30 and this is 30. So this came in your mind first, then you have resolved. Okay, but what if this came in your mind first? What if this comes in your mind first? What? So this thing, so this is a ball, this is the tension T, okay, and this is when 30 degree. So obviously this is going to be 60 degree. This is going to be, sir, how much? 60 degree. Okay, now if this 60 degree you sort out first, so what is going to be the component here of this T? So this is going to be T cos 60 and this is going to be T sine 60. Okay, so both the ways you are going to get the correct answer. Yes or no? Okay, so depends upon what angle comes in your mind first. Okay, what angle comes in your mind first? Clear? Please answer me. Please answer me, beta. Okay, wonderful. Let's do one question. Yeah, an aeroplane. Let's solve this question. An aeroplane takes off. An aeroplane takes off at, just one moment. Yeah, an aeroplane takes off at an angle of 60 degree, at an angle of 60 degree from, angle of 60 degree from horizontal, angle of 60 degree from horizontal. Okay, if the velocity, if the velocity of, if the velocity of the plane, if the velocity of the plane is 200 kilometer per hour, okay, 200 kilometer per hour, calculate, calculate if horizontal and vertical components. Okay, please go for it. I'm very sure we can do. Please try to solve this one. Very, very simple, my dear. Very, very simple. Right? Why, sir, you are giving us this question? So, see, I don't want you to make any mistake in the case of resolution. Okay? Because, see, if resolution goes wrong, you are deprived of understanding of many, many topics. Please do it. Bima, what about you, beta? So see how we can do it very, very simply. So it says an aeroplane takes off at an angle of 60 degrees from horizontal. Okay, so uh, we have to visualize it, how we are going to have it. So the aeroplane took off at an angle of 60 degrees from horizontal. If the velocity of the plane is 200 kilometer per hour, if the velocity of the plane is 200 kilometer per hour, find its horizontal and vertical component. So now please understand this. So what this question is trying to tell you, and from here you will understand, the relevance of resolution also. So some plane took off like this. Okay, that usually takes off. Okay, so now it took off like this. So it has moved in both x and y together. It has moved in both x and y together. Okay, so how much is the velocity in x and how much is the velocity in y, which will ultimately give you this. Okay, lately we will be coming to that also. Okay, so now this is 200. So obviously this is going to be 200 cos 60 because it is making the angle from here, and this is going to be 200 sin 60, right or wrong? Okay, so 200 cos 60, so cos 60 is 1 by 2, so it will become 100 kilometer per hour, and you can change it into meter per second if required, right? How you got to change it? So sir, we know that we have to multiply 5 by 18 to it. Okay, very easily we can do that. Now 200 sine 60 degrees, so that means 200 into root 3 by 2. So it will become 100 root 3. That is somewhere near 173 kilometer per hour. Yeah. Okay. So will you be able to deal with this thing? Yes, sir, definitely, sir. We are very sure that we'll be able to deal with it. Now, please understand this. One very important point is, sir, not always it is necessary. Please understand this. Not always it is necessary that we resolve or we find the components of two vectors. It is not always necessary that we require the components of two vectors or we find the component of two vectors in x and y direction only. Okay, it is not always necessary. See, according to the demand of the question, according to the need of the question, we may we may find the components in any two mutually perpendicular directions. So the very important point is that we can have what we can have, sir, we can have two mutually we can have two mutually we can have two mutually perpendicular we can have two mutually perpendicular we can have two mutually perpendicular components of a vector. We can have two mutually perpendicular components of a vector of a vector of a vector other than other than x and y directions. Okay. Okay, so what we can do, sir? See, depending upon the need of the question, we can resolve any vector in any two mutually perpendicular directions other than x and y. Okay, like for example, let's say, so this is a very standard case, and the result of it normally, is students memorize. Okay, so you can do also the same thing, or you can resolve in a moment. Okay, so this is the inclined plane. This is the inclined plane. So we know this is the inclined plane. Now see what happens. So we are having, let's suppose, a body here. Okay, we are having some body here like this. Okay, we are having some body here like this. Okay, okay, and now please understand this. Let's suppose this angle is theta. So here in this case, normally, sir, we will be required to find because see, when we are going to deal with this in, friction or dynamics, you will be needing the component of the forces in, so this is the weight always acts upside down. We know it now. Weight of always acts in this direction, downward direction. So this is the weight W, and now I want the components of this W in the axis parallel to the inclined plane and perpendicular to the inclined plane. Can you try that? See, I want the components of this, force, the weight in the direction parallel to the incline and in the direction perpendicular to the inclined surface. Can you try it for me? Yeah. What about the rest of you? What about the rest of you? She said, that's a good thing if you are good. Because the NEET have the combined syllabus of both 11th and 12th, na? Okay. Don't worry, don't worry. Don't worry. Trust me on that. Mechanical properties of fluid, mechanical properties of solid, all this we are going to learn very well. Don't worry. That is actually the area of my expertise. I'm a mechanical engineer now. Right? Okay. Okay, so let me do it for you. Now please understand this. So this is theta. This is theta. Now this is theta. This is 90. So obviously this is 90 minus theta. Sorry, this is also theta, right? Because this is, see, see, this is theta, this is 90. I think, see, October it is, so by December, okay? So now this is 90 degree. So see, she say I'm trying now, right? Okay. See, I cannot rush things beyond a certain level, okay? See, what I can do, I'm taking, see, 2 hours, 2 hour, 30-minute classes, right? Okay, so we are trying from our side as much as we can do. We will be definitely be doing that. So now this is 90, this is theta, so this is 90 minus theta, so obviously this is going to be theta. Okay, now please understand, see, the important point here is that whenever you want to take a resolution of any vector, all you have to know is the angle between the axes which you want to resolve that vector to. So if this is theta, obviously this will become w cos theta. This will become, don't worry about it. We'll come to that chapter very soon. Okay, so this is going to be W cos theta and this is going to be W sin theta. I hope it is fine to everyone. Yeah. So how come? See, we come to know this now. that the angle with whom the axis is making the angle with, okay, you can see this like this. So w is this is theta, so you can get this w cos theta, and then this is w sin theta. Clear? Yes or no? Please answer me. So see, this is a very standard case. You may know memorize, or you can keep it in your mind that whenever in an inclined plane there is a object, there is a body. So the component of it in the direction parallel to the plane of incline is w sin theta, and perpendicular to the plane of incline is w cos theta. Okay, very simple, no? Very simple. Okay, so you can memorize this also, right? Right. Now, similarly, if I say, let's suppose, let me make a question out of it. So, let's suppose, okay, I'll just see one question if I can give you. Ha. So, we have a question here. Let's just, after this, I'll be, we'll continue in the next session, because see, the resolution thing is going to be completed. Then in the next session, we'll start with the unit vector concept. And lately we'll be going with the orthogonal unit vector, then we'll be seeing the Cartesian coordinate. Though this, resolution is a lot of use. Okay, so basically we have reached, please understand this, we have reached the vector to the stage that we can continue with the motion in a straight line thing. Okay, so in the next session, rather than coming up with the vector, I'll come up with the graphs in kinematics. Okay, and in 1-2 more sessions, I'll be completing the vectors completely, and afterwards, both of these will be completed. So both of your chapters will be completed, I think, within 2 to 3 days. Okay, 2 3 days, I'll be completing both the chapters. Thanks, Shitai. See, you are a serious student, beta. That is also the reason for the same. Okay. See, if someone get bored in the classes, see, there are different way of teaching. Okay. So, see, I try to give my 100% to the content what I provide you. Okay, because that is something of utmost important. Okay. So the velocity of the boat. Let's do this last question and then we can call it the day. And in the next session, it's the very important session. We will be coming up with the graphs in the kinematics. Very important chapter, very important part, because that is little tricky. Okay. So see, in those graphs from kinematics, what happens to be what shore line? I'll tell you. So see, what is shore line? Let's suppose that there is a sea, and in that sea someone is rowing the boat. Okay, now there will be some shore at far away. Shore is like the land. Okay, now he has to move in that direction, he has to row in that direction to reach the land. See, this is the let's suppose this one. See, let's suppose there is a island here. This is the island. Okay, this is the island, and some boat is here. Some boat is here. Hello, Vivek. Some boat is here in the sea. This is deep sea. Okay, this is the sea somewhere here. Now, okay, let me make the here, let me make here. Okay, this is your boat. Let's suppose this is your nice, beautiful boat. Okay. Now see, you want to reach the island, so you have to row in this direction. Okay, you have to row like this. Okay, so when you follow this shoreline, this path, okay, you will be rowing in this direction to reach the island. Do you understand that? So this is what we call as the shoreline. Sometimes it is also known as the coastline. Okay, coastline, shoreline, these all the marine engineering terms, right? So shoreline basically is the route in which you must row your boat to reach the land, the shore. Okay, now please do this. This is shore, not shore. Vivek, hello my dear. So Vivek, what we are doing here, beta, we are trying to the path of the swimmer. Yeah, the path of the swimmer in order to reach the shore. Please try to do that. Very, very simple. See, I'm just trying to give you, more and more context of the resolution so that you are, becoming good at it. Please go for that. Please go with that. Please try to solve it. See, first of all, see, language, understanding the language of the question in physics is also very important. Waiting, no worry. So, understanding the language is also very important. You're not, don't worry. Just try a little bit more harder. A man rows a boat with a speed of 18 km/h in northwest direction. The shoreline makes an angle of 15 degrees south of west. Obtain the components of the velocity of the boat along the shoreline and perpendicular to the shoreline. That is the crunch in this question. Na? See, if you understand the language of it, there is nothing left in the question. You try first, then I'll do. Don't worry. You please try once and let us do that. Then I'll do. No worries. Tell me when I can do it. Okay, let's see it. I'll do. So it says a man rows a boat with a speed of 18 km/h. So this is our north, so east, west, north, and south. Okay, east, west, north, and south we are already having. Now the man rows a boat with a speed of 18 km/h in northwest direction. So what is the northwest direction? So basically this person is moving in this direction. This person is moving in this direction with a velocity of, so let it be v only. So with the velocity of 18, with the velocity of 18 km/h. Okay, let's call it v. No worry. The shoreline makes an angle of 15 degrees south of west. Okay, so 15 degrees south of west. So from west, you consider axis. So if I consider south of west, 15 degrees south of west, this must be that axis, right? This must be that axis. Now, you make one perpendicular axis to it as well. So if this is 15 degree, okay, you make a perpendicular axis. So this is your shoreline and this is your axis perpendicular to the shoreline. Did you get that? Yes or no? Okay. Okay. Now if this is 15 and this is 45, obviously, why? How sir it is 45? Because it is written that it moves in the northwest direction. So when it is moving in the northwest direction, it is 45, right? Yeah, you are wrong. So this is 45. So how come we know that it is 45? So I told you, when it is written northwest, so that means that the direction is exactly between. The direction is exactly between north and west. So it has to be 45 degree. It has to be 45 degree. Okay. So velocity is 45 degree. It's making 45 degree here. Okay. And this is 15 degree. This is 15 degrees. So you want to resolve this. You want to resolve this in the direction of the shoreline. So see, this is 60 now. So this is going to be V cos 60. Okay, V cos 60. And now this is 60. So what is the component on the perpendicular axis? So V cos 60, this component will be V sin 60. Please tell me if it is fine or not. Huh. So if you remember, see, that is why, see, Shizai, I always say, see, small details are very important, right? So if you remember, I taught you that how to see the direction also east, north, west, south. Okay, it is highly useful thing. Okay, because at times when in a bigger question this information is presented in this way, you will not be able to form the question. If you cannot understand the question, obviously you will not be able to solve it. Yes or no? How can you solve a problem which you don't understand? First step is to understand the problem. Then you can approach it. Right? I hope it is clear to everyone. What about the rest of you? Now, can we say that, so V, sir, we can put the value 18, we can get then. So if V is 18, cos 60, so 18 by into 2, it will become 18 into cos 60, that is 1 by 2. So this will become 9 and 18 into sine 60. So this is 18 into root 3 by 2. So that is 9 root 3. I hope this is clear now. She said, yes or no? Yeah? Okay. So guys, I think that we can stop this session here, right? Okay. So till now, see, I want to tell you something. So till now in vectors, we have done enough to proceed in the motion in a straight line thing. Okay. Okay. So what I'm going to do in the next session, I'll come up with the graphs in kinematics. That is the graphs in displacement time, velocity time, acceleration time, how you use them, how you interpret them. That is a big zone of kinematics and very very important and very very tricky. Students find quite difficulty in moving from one to another. Okay. Okay. So in the next session, I'll be coming up with that. Also, we know that the 75 days challenge series has also started. And basically, we every day we are coming up with some 10-15 questions. So today I did it at 2 p.m. And we have solved some 10 questions in that session. Okay. Okay. So you may also come and join that. If not possible in the live, you can watch the recording. Okay, and you can share with your friends also. So guys, in this session we have reached the vector to a stage. We have done the basics, right? Angle between the vector, so many things we have done, types of vector, this that. Okay, then we have done a very important part, that is addition subtraction of vector through graphical and analytical ways, right? And now today we have done something in resolution also. Okay. Okay. So in the next session I'll be coming up with the graphs in kinematics, and I will continue the vectors from this point, from the upcoming of the next section of the vectors. Okay. So please subscribe the channel so that you get the notification that when what the topic is going to happen here. Okay. And I hope you are enjoying our journey of physics together. Okay. So guys, with this, thank you very much. Have a good day, and we'll see you in the next session with graphs and kinematics.